as well. We talked about converting binary into denary, where you practiced as well. All of you did well. I am repeating, if you have a problem, you'll let me know. We talked about binary addition as well. Okay. Obviously, we talked about that kilobyte, megabyte. Obviously, you know that, how much 1 gigabyte is.
Sir, can we please talk about two complement thing?
Yeah, I'll talk about two complement. That's very good. Now, for example, I have the following. Okay, I have the, sorry. So let's say I have 1, 1, 0. Let me use underscore for this. So I'll just make it great and I'll explain you through that. So here we go. I 1, 2, 1. One, two, three. So in case if I have is 1, 0, 0, 1, 0, 0, 1, 1. Okay. And what I want to do is I want to find the two complement of this. Okay. Let me just increase the size so that it's visible to all of you. Right. So the how two complements work is your one's complement basically says is that you are going to inverse all the digits. Okay. Meaning that you will convert the zeros into 1 and ones into zeros. So if I do that, obviously I will end up with what? I will end up with inverting this is 0, 1, 1, 0, 1, 1, 0, and 0. So that's the ones complement, which means you obviously simply just have to invert everything. Ones into zeros and zeros into ones. Your third complement basically means, so we are here now, okay? We are here now. Third complement says that you need to add 1 to it. Now, if I add 1 to it, what do I have? Okay, we talked about addition. We talked about that. So if I add 1 to 0, what will happen? 1 plus 0, I'll get 1 here. I will get 0 here. Okay, so I'm adding this. So I'm not adding the first row, okay? The second row and the third row. The second and third row. So I'll get 1 here, 1 here, 0 here, 1. I'm so sorry. 1 here, 1 here, 0 here, 1, 1, and 0. So your first complement says to inverse. Your second complement says that you need to add 1 to it, and this is how you get the two's complement. Is that clear?
Yes, sir.
Right? That's how you get the two's complement. I'll leave this open because I want to discuss something else as well related to this. So yeah, hexadecimal system. Yeah, I think so. We did not discuss this, but again, your hexadecimal as hexadecimal means is still 16. So a hexadecimal system is used in a lot of places where you want to represent more numbers. So a 16-base system. So the weightage, like in case of binary, you have 1, 2, 4, 6, 8. Okay. In decimal system, you have 10, 100, 1,000, so on. In hexadecimal, obviously, it grows exponentially in this form. Now, the important point to note over here will be that as far as your hexadecimal system is concerned, so that's your binary value from 0 to 9. So 0 till 9, I have the following. No problem with that. Then how do I continue with it till 16? After 9, we start writing A, B, C, D, E, F. That's how we represent. So A represents basically your 10th, B represents your 11th, 12, and F represents 15. So whenever we want to represent hexadecimal value in binary value, we would always know that A is basically 10. I would always know that D is 13, and I would always know F is 15. This is something that we need to remember for the conversion. So if I know this, that my hexadecimal values go from 0 till F for my first 16 digits of denary, how will I be converting from, let's talk about this, from converting from binary to hexadecimal. So if you want to convert from binary to hexadecimal, we did talk about how to do that before, even when we talked about binary coded decimal. Okay, remember we talked about B binary coded decimals, sorry, BCD binary coded decimals in the class. What was that? So first I will split these into 4. Okay, after splitting these into 4 of this. So always we will. So these are your nibbles. We call them 4 nibbles. So every nibble will be converted. So if I convert, let's say the first one, what is this? This basically, if I convert this particular value into binary value, this is what? This is 1, 2, 1 plus 2, because this is 1, 2, 4, 8. So what do I get? I get over here is 1 plus 2, 3, 3 plus 8 is 11, and 11, like I just told you over here, 11 is what? 11 is B. So this means that's B, obviously, right? Then I have what? Then I have over here is this one. This is 0, 1, 2, 4, 8. So 2, 4, 8, 6 plus 8 is 14. So 14 is E, as you can see over here. And obviously you remember this. So here you get it. You get E. And obviously this is 1. So if I convert the following binary value into hexadecimal, I get is BE1. Let's do another one. So I have this much larger value. I will again split this into a group of 4. But doesn't matter. Your last one could even be 2. You can even convert that. That's not an issue. Okay. So you can even have 2. But first of all, you have to convert all of them into group of 4. And this you're doing from right to left. So this will be converted into 2. This is 1. This is F. This is the maximum one, F. Okay, this is 15. If you add them up, you get 15. And that's T. So this is how the story ends about converting binary into hexadecimal. Okay. Then you have convert hexadecimal value number to its binary equivalent. Well, again, quite an easy job. All you have to do is for example, you have this BF0. So you just go the other way around. What you need to do is you will simply convert this. You have to find out that B is what, F is what. Okay, because you know F is 15. So what is the binary equivalent of 15? What's the binary equivalent of 0? What's the binary equivalent of 8? So once I get the binary equivalent of my all hexadecimal values, I simply join them up, and this is what I get. Is that clear? Any question, anyone? Clear till now? Yes. Okay. Rija, you joined late. I am sure you know all this. There's no problem. I was thinking tomorrow I'm going to take your online assessment. So for that, I was just somehow revising all this so that all of you do well and there's no excuse. So that's how, okay. So hexadecimal values are used in memory dumps as well. Why over there? Because memory dumps basically include a lot of information. We don't have to go into that. What information does it have? So they're used in places where a lot of information needs to be stored. So there we use is hexadecimal values. Binary codecimal, we did discuss this. So we know it. If anyone wants, I can revise, but we had a discussion on this. There's no point of not wasting time. Ascii and Unicode. Now we have two things, Ascii code and Unicodes. Well, since I've opened MS Word, let me just show you that over here. If you just have a look over here in your more symbols, you will see over here is a Unicode text. If you can see down over here. Okay, and I can even have is an Ascii representation. Well, the difference between Ascii and Unicode is Ascii was basically invented by Americans for English. But this was not sufficient because other languages such as Arabic, Persian, and lots of other languages, Chinese, Japanese, their characters wanted to be part of it. Because obviously everyone was developing their own system, their own operating system, their own application softwares. So they came with a universal code where all the characters could be represented. And this was now known as Unicode. It's Unicode hexadecimal that can hold lots of values. Okay, so that's all what that you should be aware of. Okay, nothing much than that. That's your part of the Ascii code, and Unicode can hold lots of more characters. As you can see over here we simply have the basic 256 characters that we have, which are used in English. But if you look at the Unicode, there's so many characters that can be used for other languages as well. Lots of codes. Okay, even more than this. Right. And when we refer to 256, we refer to Unicode now. Okay. So see, there are lots of. Multimedia, yeah, we discussed bitmap images. Stick with me if there's any problem. Image resolution, we talked about vector-based, we talked about bitmap-based, right? We talked about calculating the image file size. Okay, we had a discussion on that, how to image size. We know about the properties of vector graphics, okay, right? That you should have a list of properties of vector graphics. You should have a list of properties of bitmap graphics. A very good comparison that you have over here. Okay, a very good comparison, I would say. In fact, what I can do is this particular comparison I can share with you in the group as well. It's really a very good comparison. So that we can remember. This is our class. This is IT. It will be shared with you. My phone is not connected. I'll just connect. It will be with you. Then we have is just able to see SVG and all that. Right. Like I said, you can tell me to discuss if you want me to discuss a point. Sound files. We talk about frequency, right? This period, the pitch. Okay, right. We talked about the samples, how many samples there are. That's the interval. Okay. We talked about all that. Video, frame rate, buffering, lossless, lossy file compression, okay, MPEG MP3. MPEG MP3 is not very important. I didn't discuss with you, it's fine. Run length encoding. We did not discuss that. I'm going to discuss this with you. Okay, this is why I'm revising, because I want each and everything to be discussed properly. So run length encoding is one of the ways that you can compress an image. Run length encoding. How does it work? It's a very good way. Now, repeating strings. There were repeating strings. What we did was, for example, if I have is somewhere in an image I have over here is so over there what is if black is appearing like 20 times. So 20 times B would appear. I'm just giving an example. The B will appear at the back of that image 20 times. So instead of writing B 20 times, what we'll do is we'll just write B multiplied by 20. Now, what is the advantage to it? B multiplied by 20 is holding 1, 2, 3, 4 characters. On the other hand, you're writing B 20 times was taking 20 characters. So you have actually saved 16 characters. So a repetition of characters was saved because information is saved in the form of characters. That's what we're trying to save. तो वो save हो गया. इसको run length encoding कहते हैं. We'll look at more examples. आप देखो text data, run length encoding on text data. We'll talk about run length encoding with regard to data on with text. We will talk about run length encoding with images as well today as well. So for example, ये आपका कोई information है, okay? So in case of text, you see, I can just write this as 05, so 1, 2, 3, 4, 5. Why 97? Because 97 is the ASCII code for A. Okay, so I can write 597 instead of this. B, the ASCII code for B is 98, so I can write 4. I can write 2. Okay, at times it takes more character, but it's fine because you have to follow the rule. Generally, it will be an advantage. And 5. So that's how you do it. The repetition of the characters is multiplied by the numeric value, how much is being repeated. Okay. In case of images, the run encoding works in a different way. As you can see over here, this is my screen, and let's say I've written is F, as this is black and white image, for example. So you can see is if I look at the representation at the back end with ones and zeros, this is the way it's happening. Where I can see white, it's 1. Where I can see it's black, it's 0. You can see over here. So wherever it's off, because obviously when it's off, it's black. Whenever it's on, it's 1. Then how is it compressed using RLE, run encoding? So you can see what it is. That's the way we'll do it. We'll start from the very top and we'll go this way. Okay, we'll go this way. So I have 9 white, 1, 2, so 9 whites. You can see I have 9 whites over here, 9 white. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'll go this way, and this way. So that's the way we'll go. That's the way we'll go. Then I have is 6 Bs, 6 blacks. Then I have is 2 white, right? And then I have is 1 black, 7 white, so on and so forth. So white is 1 and B is black. So this is how we've been able to get it. So instead of writing so many characters, we've been able to compress it. In colored images, that's the way it works. Now, you do know is that black is always 1, white is always 255. Let's talk about this. Why 255? Well, your RGB, red, green, and blue, your red, green, and blue colors jo aapke hote hain, they go from 0 till 255. So this means red has a color, has 255 different color combinations, 256 to be precise. Green has 256, blue has 256. So 255 multiplied by 255 multiplied by 255, this is the color palette that you see in your color mixture of any graphic software. Itne millions of colors hote hain. Kehne ka matlab ye hai ki when you have pure white or your all are basically on, you get white. Green ke liye kya hoga? RGB. You can see RGB. So red is off, green is full on, and blue is off. Pure green. Red mein kya hoga? Red is on, green, and blue is off. So blue mein kya hoga? If blue was here, 0, blue would be 0, 0, and 255. That's the way it's represented. Now, if you look at this image, now this is the way it's done. So what do we have here? You'll see over here is I get 2. I have 2 over here pixels, which are basically what? For black. That 0, 0 is black. Remember that. Okay. 4 times is this. What is this? 4 times green. As you can see over here is, this is green. 3 times black. 3 times black. You can see that. 3 times black. This is green. Okay, 6 times. And 6 times is white. 6 times. So we're not writing times over there, but 6, that's the way it's done. Okay, 255, so on and so. So this is the way your information is basically decoded, and that's how run length encoding works. You might think this is a lot, but no. If we would have written all of these, there would have been more. And this is why at times you might have noticed that when you compress an image which is inside your house and you compress it, it doesn't reduce more, but when you compress it outside, for example, sorry, when you reduce it inside your house, it's reduced to a lot of extent, but when you reduce it, when you take a photo outside, it's not reduced, because over there, there will be less chances of compression. It could be any particular case. We don't go into that detail, but whatever it is, that's the way it works. So next, what do we have? Movies, image files. I hope I'm not talking to myself. You're with me. Rija, you there, beta? Okay. Right, fine. The rest of any problem? तो इसमें फिर हमने ये नेटवर्क का चैप्टर था. इसमें we talked about LAN, WAN, right, public networks. बात हो चुकी है सारी. Why to repeat? वैसा पॉइंट आता है तो मैं बता दूंगा आपको. Wide network discussion कर ली थी हमने. Okay. Client server model, we talked about it. Client server model. Okay. You should have a list of properties of client server model. Again, this is really nice. I will share this with you. It's a very, very nice explanation. Okay, that you should have. In fact, I'll share the entire PDF file in the group. Why not, Hannah? Let me share this one as well. You should have this reference book as well. It's pretty good. Okay. Wait 1 second. Someone messaged me. Yes. Okay, now what we have is examples of client server model, right? Right. So this was your peer-to-peer or your MASH, where all the computers are interconnected to each other. We have discussed it. Okay. Now there are two terminologies which were not discussed in that context, but we'll discuss it over here. It's very important. So basically, is why is that unstable? Okay, a thin client is heavily dependent on having access to the server. For example, in a star topology, if the client is accessing on the application softwares, okay, from the server, it will be considered as your thin client, which means it cannot load anything only if the server is on. It's totally dependent to a lot of extent on the server. Thick client can either be a device or software that can work offline or online, which means it will have sufficient hard drive of its own, it will have sufficient RAM of its own, it will have its own operating system that can run independently and work independently, as compared to a thin client, which is dependent upon the server to do something. Then why do we need thin clients and why do we need thick clients? Well, obviously, if you want the users to work on applications that tend to be pretty heavy and you want them to independently work, then obviously thick client. But at times there are such environments where you don't want your clients, your users, in the word, you don't want your users to use such heavy applications. They just have to probably browse, fill in some questionnaires every day. They belong to marketing and all that. They just come in, they fill up and we go. So we can work on thin client. We don't really have to heavily invest on the client computers. We'll simply invest on the server. I'll share the entire PDF file of this book with you. I can't obviously cut and paste everything. We talked about bus topology. We talked about star topology. Okay, we talked about mesh topology. We have done all this. Okay, we talked about hybrid. Hybrid was what? This is your bus and this is your star. So your star topology is basically on the bus. Okay, so the different ways you can connect your topologies. Public and private, we also talked about that. Okay, cloud computing. Okay, hybrid is a combination of both of them. A combination of both will basically be known as a hybrid. Right? Pros and cons of, you can go through this as well. Okay, you can even ask me in the evening as well if you have a problem. Okay, cloud software is fine, Wi-Fi, Bluetooth. We have done all that. Okay, we talked about satellites. We talked about different wireless technologies, and we talked about communication methods to communicate, in which twisted pair cables and coaxial wires. Okay, fiber optic. Wireless technology basically was Wi-Fi. Okay, how it can be used. Okay, right. Hardware requirements for a hub is a dumb device that simply connects the computers to your server. It does not work on IP addressing. Okay, it's simply used in small networks such as a bus or a circle or ring topology. We talked about gateway. Gateway is a device, or it's an interface that can help, that makes the user communicate with some other environment, such as someone working within a LAN wants to communicate with the WAN. Your router will be a gateway that will allow you to do it through the ISP. So if, right now, the router at your home is your gateway. Your personal computer is connected to the World Wide Web through the gateway. Switch is an intelligent device that connects to multiple computers with the help of IP addressing. Repeaters are basically used within the LAN to enhance the dead spots and to repeat them so that the signals do not deteriorate when they're transferred over a long distance. We call them repeating hubs as well. And there are obviously, the reason that we use them is obviously to repeat, to enhance the signals. Bridge is used to connect multiple LANs together. It's just a device that connects bridges to LANs together. A router, basically, we talk about the routing table. It just helps us to tell the destination, the routing, IP addressing of different computers within a network. Okay, which data has to go through which IP address to which computer. Okay. Right. Again, a discussion of gateway, modems, and all that. We talk about modulation and we talk about demodulation as well. Right. And network interface, I talked about Ethernet as well, if you remember. Wireless and network interface card. Okay, we talked about this as well, if you remember. Okay. So that's wireless network card. Last week, we talked about Ethernet. Okay, through the coaxial wire, you can connect to your laptop. You have Ethernet everywhere. You have in the back of routers. You'll find Ethernet even at the back of your LCD TVs nowadays. You can directly connect through a cable over there. So switches ke back pe hota hai, hubs ke back pe hota hai. So router is when you physically have to connect your cables to a device you use is an Ethernet for that. Usko Ethernet cable kehte hain, usko Ethernet protocol bhi kehte hain because it's a medium through which data packets and data is transferred. Okay, the addresses are often the MAC address. MAC address इसलिए तो बात हो रही है क्योंकि physical exist करता है. Every device that will have a physical address is known as a MAC address. Okay, right. We talked about exclusions as well. Carrier sends multiple exclusions. Detection मैंने last time बात की थी आपसे कि within the network there is this property within the network that helps the data packets not to collide with each other. Okay, and they will sense when one PC is sending the signal, the other will not send the signal, so that it will detect and there's no collusion and there's no destruction and elimination of data packets within the network. This method is known as your CSMACD. Okay, because हम last time इसकी बात कर चुके हैं. Bit streaming, we talked about bit streaming. Bit streaming का ये है कि buffer fill up होना चाहिए. The bits that are coming in from the server, they get filled up in the buffer before they play to the media, so that we constantly keep on seeing the video as it gets on playing on. Okay. और इसके बाद the internet, मैं देख रहा हूँ हमने discuss किया कि नहीं किया. When I will stop over there. Switched phone calls, cellular satellites. Discussion हमने की हुई है, मगर I will limit myself. मैं इससे पीछे रहता हूँ. So we'll just stick till here. That's quite enough. क्योंकि content काफी ज़्यादा है, but it's very important. Frankly, this is like if you talk about P1. This is around like 30 marks of P1, 30-35 marks questions इसमें से आते हैं. Total आपका याद रखना 75 marks का P1 होता है. So ये 40% इसमें से questions आ जाते हैं. Yes, any question with anyone? Or I was just talking to myself. I just ran through it and I just discussed everything. Still, there is any problem, you can ask me. Okay. Yes, anyone? No problem? Muriba, Hajra, Fatma?
Yes, sir, no problem.
Okay. So maybe I'll just share this will with you as well. आप लोग इसकी तैयारी करो, ठीक है? I'll stop now. कल मैंने आपको इसका ऑनलाइन दे दूंगा टेस्ट and फिर हम आगे start करेंगे. Because before I wanted to continue with the next topics, I wanted to just assess you a bit on all this. And I wanted you to revise till here. I wanted to see how it's going. Okay. Theory khatam karna, it's not a big deal. I can finish the entire thing in the next 1 month even. Magar, I want to see how it's going. Right? Okay, better then. See you tomorrow. Okay? Okay. You have time, you can revise. You can revise, okay?